want to talk to you a little bit about today is I was going over your work from last week, from April 20th through the 24th, and I noticed that there was several people that had some misconceptions about the periodic table. So I wanted to talk a little bit about that. So as you can see on the screen, you can see have a copy of the periodic table. So I'm going to kind of show my mouse over here. I hope that you can see it moving. So most of you guys got that the periods, okay, are going to be going across. Think about it if you're writing a sentence, okay, then you always put a period at the end of the sentence. So that would be a horizontal. Okay, so some things with each of these periods that that is going on is that, as you can see, that the atomic number, it is increasing by 1. Okay. Also with the periodic table, or with the groups for all of these different periods. So this would be period 1, 2, 3, and so on. Another thing that they have in common is that each of the different periods is going to show you how many electrons that you will have in the electron or in the energy shells. Okay, so in this case, as we know with hydrogen, it only has atomic number of 1. So in that first energy shell, it's going to have just 1. All right, if you go down to lithium, okay, remember that in the first energy shell, there will be 2. In the second energy shell, there would be 1, right? 2 plus 1 gives you a total of 3 for the electrons. So all of these going down in the outermost shell is going to have 1 electron, okay? If I go over here, all right, let me go over here to helium. You can see there's 2, all right? So that's just going to fill up the energy shell, okay? Because let's remember that in the first energy shell that you would just have 2 electrons, okay? So I wanted to talk about that, and the importance of that is that that has to go along with the reactivity. So remember that if there's only 1 electron in the outermost shell, is that it wants to join somebody else that would have that would just be missing 1 electron, and that way it's going to join together. All right, so if I was to take, say, hydrogen, all right, so I know that there's just 1 electron here, and if I join it over here with fluorine, okay, because fluorine would then have, in the first energy shell, it would have 2. In the second energy shell, it would have 7, right? 2 plus 7 is going to give me my 9. But remember that in the second energy shell, it can hold 8. So it's just missing 1 electron in order for it to be considered to be full. So that's why if I wanted to combine hydrogen and fluorine together, that's going to give you a pretty big explosion, okay, or a reactivity. And hopefully you guys maybe discovered that when you guys were playing around with that simulation a couple of weeks ago. All right, so that's talking about the periods. The things with the groups, so as you can see here, here you have group 1, 2, 3, all the way up through 18. All right, so what they have in common is that these all have similar properties. Okay, so like with group 18, you can see that you got helium, neon, argon, krypton. I said all these are noble gases. All right, so for each of them, I said you don't need to know a lot of all the different properties. You can see a lot of these in here are metals, so that they would have kind of the same properties. All right, so that's the importance of periods and groups, and the difference between the two of those. All right, hope this helps, guys. I will talk to you later. Bye.